Alright, so this is the Chapter 8 review worksheet. Alright, so finding the three trig functions. Again, reading the directions will kind of tell you what you're trying to find here. So we're trying to find my sine of theta, cosine of theta, and tangent of theta. Okay, so to find that missing side, we have to use Pythagorean theorem. So my c is always across from my right angle, so 9 squared plus 12 squared equals c squared. Opposite of squaring is square rooting. So in your calculator, you're typing in the square root of 9 squared plus 12 squared. Okay, so I get 15. Then I label it. So I always look at it from my given angle, so theta. So I've got my opposite, adjacent side, hypotenuse. So in my SOHCAHTOA, my sine is O then H, so 12 over 15, which simplifies to 4/5. Again, if there's a square root in the bottom, you multiply by the square root, top and bottom, to get rid of it. Okay, cosine is A then H, so 9 over 15, which simplifies to 3 over 5. Tangent is O then A, so 12 over 9, which simplifies to 4/3. We're not trying to find the angle, we're just trying to set up our fractions here. Okay, my next one, we're trying to find all the missing parts. So it says angle A is 37, B is 15. Okay, so there's 180 degrees in a triangle. So to find angle B, we subtract my 37 and 90 from 180, and I'll get 53 left for angle B. Angle C is always my right angle, so my 90 there. Okay, so then missing sides, I always start looking at it from my given here. So if I redraw it, I've got 15, I'm looking at it from 37. This one I'll find A. And this one I will find C. Okay, so I'm going to label my sides based on what I'm having here. So if I'm looking at it from 37, I've got my opposite and adjacent. And I've got my adjacent and hypotenuse. Okay, opposite and adjacent is tangent, so tangent of my angle equals, it goes opposite and my adjacent. So I multiply both sides by 15, and I type in 15 tangent of 37. So I get my A to be 11.3. Okay, you could use Pythagorean theorem to find your other one, but I already set up trig, and it's A and H, so cosine of my angle equals my adjacent over my hypotenuse. So this is the one where I have to multiply by C to get them out of the fraction, and then divide by my cosine of 37. So really what I'm typing in my calculator is 15 divided by cosine of 37. Which is 18.8. And remember, your C should always be your longest length or across from your hypotenuse. Okay, my next one, I have A being 2. I have C being 9. I can use Pythagorean theorem to find my last one. So I've got 2 squared plus B squared equals 9 squared. So I subtract 2 squared. I get B squared equals 9 squared minus 2 squared, and square root it. And I got 8.8 for my side B here. My right angle is going to be C, so 90. So let's say I want to find A first. I could put a little theta or X in there. Okay, so I'm going to write in, so I got my 2 and my 9, so I'm going to label my two given sides again. So opposite and hypotenuse. So that's going to be sine of that angle equals my opposite over my hypotenuse. Anytime you are trying to find the angle or get rid of that sign, you use the inverse. Inverse always happens when you are looking for an angle. So inverse sine will get me my degree that I want there. Okay, and I got 13 when I typed it in, so 13 degrees. Okay, so that represented angle A. Okay, then I could do the same thing, or I could just subtract them from 180. So 180 minus my 13 minus my 90. And I have 77 degrees left. Okay, my next one, draw an angle measuring negative 135 in standard position. So remember, negative goes opposite, so clockwise, 0, negative 90, negative 180. negative 270, negative 360. Okay, so negative 135 needs to sit in between my negative 90, negative 180, and it comes clockwise. Rewrite each, we're converting from radian to degree or degree to radian. So if I'm trying to get my pi in it, I want to multiply by pi over 180. If I'm trying to get rid of my pi, it's 180 over pi. Okay, this answer is going to be negative here. So 190 over 180 is going to be 19 pi over 18. My next one here is going to be negative 216 degrees. Okay, find one angle with the positive measure and one angle with the negative measure of the coterminal of each angle. So degrees, we add and subtract 360. Radians, we add and subtract 2 pi. So you can either, if you have the L calculator, just type in 3/4 plus 2, 3/4 minus 2. Otherwise, we'll have to change the common denominators. Okay, so negative 29 plus 360. So my positive side, I'll get 331. My negative side, I will get negative 389 because negative 29 minus 360. Okay, if I don't have the L calculators, I have to get common denominator. So I need to multiply by a form of 1. That gets me a 4 in the bottom, so 4 over 4. So 2 times 4 on the top gets me 8, and my 4 on the bottom. 8 divided by 4 is that 2. So 3 plus 8 gets me 11 pi over 4 as my positive. My negative side, 3 minus 8 gets me a negative 5 pi over 4. Okay, find the exact value of the trig functions based on my standard positioning. So this is x and y, so that means I go left 4, because it's negative, and up 8. Build my right triangle. I'm going to use Pythagorean theorem to find my last one. Remember, always plug in positive. So since I'm missing c, I'm going to end up doing 8 squared plus 4 squared and square rooting it to get that c value. Okay, and I'm getting 4 square root 5 as my answer. Then I need to find my sine of my reference angle, cosine, tangent. Okay, so equals. This is 4 square root 5. Okay, so sine is opposite over hypotenuse, so I look at it from my reference angle here. So opposite, hypotenuse, adjacent. So opposite over my hypotenuse. Okay, if I simplify my L calculator, I can use a fraction button. Otherwise, to simplify manually, I'll do my 8 and 4. And then to get rid of my 5, we multiply by the square root of 5 over the square root of 5. So 2 square root 5 over 5 times 5 gets me 25. I square root it, I get back to 5. So it kind of just makes that square root go away. Cosine is adjacent over hypotenuse. So I simplify my 4's. And then multiply by the square root of 5 over the square root of 5. So that square root of 5 will go on top, and it will just become a regular 5 on bottom. Tangent is opposite over adjacent, which should just simplify to negative 2. Now we want to double check to make sure our negatives are good. So all students take calculus. Sine should be my only positive one, and it is my only positive one. My cosine and tangent are negative. Okay, because that S tells me sine is my only positive. Alright, sketch the angle, then find its reference angle. So remember, positive, we go 0, 90, 180, 270, 270, and 360. So 323 is going to sit right in here. Okay, then it find the reference angle. So I need to find closest to my x-axis, so this. All the way around is 360. I want to take off what I do know. I don't want to take off 180 because that's going to get me too big. Okay, I have to have my answer be less than 90. So I'm going to take 360 off and make sure my reference angle is positive. So when I subtract it, I get 37 for my reference angle, and I make sure it's positive. So if I would have subtracted the other way, just make sure your answer is positive. The next one, we got to convert to degree. So I want to get rid of the pi, so it's going on bottom. So negative 120. So I go 0, negative 90, negative 180. So he sits in here, goes clockwise. Okay, I want to know what this is. Okay, so right now I am at negative 120. So how far away am I? Well, if I have 120 and I take, or 180, and I take off that 120 that I have, I should have 60 left. So that means from here to here, it is 60 degrees that I have left from half of my circle. And remember, our reference angles are positive. All right, so it tells me what quadrant he sits in. So remember, it goes 1, 2, 3, 4. Okay, my opposite, this will be my adjacent and hypotenuse. Cosine is adjacent over hypotenuse. So my adjacent is, oops, I mislabeled these little guys. Adjacent, hypotenuse. Okay, so my adjacent is negative square root of 3. My hypotenuse is 2, because my hypotenuse can never be the negative. Okay? It's like the radius always being 1, so it's always positive. So then we have to do Pythagorean theorem to find our missing side so that I can find my sine of theta and my tangent of theta that's left. So use Pythagorean theorem. The tricky part about this one, so I have my c, so I'm going to end up subtracting in the center. So I'm going to do 2 squared minus the square root of 3 squared. So I'm going to get 1. Okay, so my sine is opposite over hypotenuse, so opposite over hypotenuse. Tangent is opposite over adjacent, so 1 over negative square root of 3, so we just simplify him. And then we check our negatives. So all students, so sine should be my only positive one, that means tangent should be negative, which it is. Okay, labeling my 45, 45, 90, we have an isosceles triangle, so they should be the same. My last one is x squared root of 2. My next one here, my smallest angle sits across from my smallest side. I know my 2's are on my right angle, so this one's a 2x. If I multiply something times 2, it should be across from my biggest angle. And 60 is x square root 3. Okay, use reference angles and special right triangles to find the exact trig value. So first we have to find the reference angle. So 315, it goes 0, 90, 180, 270. So 315 sits right here. Closest to my x-axis, my reference angle will be here. So I do 360 minus that 315 to get my reference angle. So 45, so if I redraw them, it is a 45, you can't really read it, 4590, so I've got my x and my x square root 2. Okay, if you don't remember what to do the negative, just make sure you do your all students take calculus at the end. Otherwise, this one should be negative because it is going down. Hypotenuse is always positive, and we went right with my other one, so we're good with that. Okay, and then we're trying to find tangent. So if I'm looking at it from that 45, this is my opposite and my adjacent. So opposite over adjacent, my x's cancel and I get a negative 1. If I do my all students take calculus, cosine should be my only positive one, which means tangent should be negative. Okay, converting, pi goes on the bottom. So they cancel. So I've got 240. So 240, 0, 90, 180, 270 sits right here. Okay, so I need to take off that 180 I don't care about. And I get a 60. So if I redraw them with my reference angle being a 60, I've got 30, 60, 90, so across from my 30 should be an x. It will be a negative x because I went left. Across from 60 will be a negative x square root 3 because I went down. And then across from my right angle will be a 2x. I label everything else. So looking at it from that 60, I've got opposite, adjacent, hypotenuse. And then we're doing cosine. So adjacent over my hypotenuse. My x's cancel, so there's a 1 left on top. And I got a 1/2. All students take calculus. Tangent should be my only negative one, or should be my only positive one. That means my 1/2 should be negative. All right, graphing. Amplitude is in the front, so amplitude is 4. That's how high it goes or how low it goes. Okay, tangent is undefined because it never ends. It's got its asymptotes. This one we have a 3 sitting in front. It's the absolute value of what it is. If there's a negative sitting there, just make sure you reflect your graph. Okay, this one is 360 divided by my number in front of theta, which there isn't one, so 360 divided by 1. So my left to right is my normal, so 90, 180, 270, 360, negative 90, negative 180, negative 270, negative 360. Okay, cosine doesn't start in the center, it starts at the top. That's like skipping 0, so my next one I have to hit is 90, and then I keep going up and down, and we keep skipping one. So I hit and skip. Try to make sure it goes up pretty close to hitting those 4 values there, so that you're showing the amplitude is at 4 and negative 4. Okay, tangent's always 180, and we're dividing it by 2 this time, so my left to right should be 90, which means I need to scale all of it. So now I take 90 and divide it by 2, and I get 45, and I take 180 and divide it by 2, and I get 90, and that's how far right I need to go, because that's what my period tells me. So then I've got negative 45, and I've got negative 90. My asymptotes occur at the first level, because I get close to them on both ends. So it should look something like that to give you that full rotation. Okay, this one, 360 divided by that 2, so 180 is how far left and right, which means I need to change all of these. So 90 divided by 2 gets me 45, 180 divided by 2 gets me 90, 270 divided by 2, 135, and 360 divided by 2 is 180, which is how far right I need to go. So then I do my negatives. Sine starts in the center, and we still have to skip the first one, so I skip my 45 and then I come back through. Skip my first one, come back through. Make sure you put arrows because they technically go on forever, both directions. So they should look like that. Okay, tangent of theta is my sine of theta over cosine of theta. Then I've got sine squared theta plus cosine squared theta. Remember, these can be written different ways. We could subtract cosine squared over, we could subtract sine squared over, we could flip tangent, which means I would flip these. We could write them as squared, so if this is tangent squared, that means sine squared and cosine squared. So just realize you can write these in a different manner. You will have to know these for the test though, so make sure you memorize them. Okay, so 23 here, I've got sine squared of theta and tangent squared of theta. So there's multiple ways you can do it. I'm going to change this tangent squared theta to, so this is my big fraction separating them. So it's going to become sine squared theta over cosine squared theta. That's what my tangent is. Then I can multiply by the reciprocal. So the reciprocal flip is going to come where that's my multiplication sign. And I flip the bottom half of my fraction. So it becomes multiplying. Cosine is on the bottom now, so he'll come to the top. And sine flips to the bottom. If I've got multiplication, I can really write it as a big fraction. If it was plus or minus in the center, remember you would have to have common denominators. Same thing on top and bottom, they can go ahead and cancel. So cosine squared theta would be my answer. Okay, my next one, I want, since I've got a fraction up here, I want a common denominator. So I'm going to multiply him by sine over sine to get it a common denominator. So 1 over sine of theta minus sine times sine gets me sine squared theta over sine theta. Because now I can bring it together. So 1 minus sine squared theta over sine theta. And it's still all over cosine theta. Okay, this 1 minus sine squared theta is one of my shortcuts. It's cosine squared theta, so I'm going to rewrite them with my cosine squared theta. Still has sine on the bottom. Still has cosine underneath him. Okay, I'm going to multiply by its reciprocal, and we're going to see kind of what happens here. So I got my top fraction. Here's my big fraction bar occurring here. So there's my top fraction. I multiply by the reciprocal. So cosine is really cosine over 1. He's kind of sitting on the top himself. So he'll flip to the bottom. So it's kind of like I have 2 cosines here and 1 here. So I'm going to cancel one set out. So I'll still have 1 cosine left on top. And I still have my sine left on bottom. Okay, cosine over sine is representative 1 over tangent. And I now have it down to one trig function.